Hello everyone, in this video we will be solving problem number 6, zigzag conversion. The problem statement is the string S is written in a zigzag pattern on a given number of rows. The example is given below. We need to write a code that will convert the input string based on the pattern that is given to us, concatenate all of the characters based on each row and return the output. The pattern is to start writing each character at each row in the downwards direction, that is in the same column, and once we are at the last row, we change the direction and move towards the top right. And once we reach to the top, we again change direction and start going downwards. Once all of the characters are placed, we start reading all of the characters at each row, join them together, and then concatenate all of the characters across all rows and return the output. It is difficult to imagine how the pattern would look like after placing all of the characters. Let's switch to whiteboard to draw this out so that we can figure out if there is any logic to solve it. One simple implementation I can think of is to use an array of size n and start iterating through all of the characters in the input string, and depending on the index of the input characters, we will add it to the corresponding rows in the array. And once the iteration is complete, we can concatenate all of the strings across all of the rows and build our output. Along with the index of the character, we need a couple of more information. The row where the character should be added and the direction in which we are heading. As there are two directions, one is downward and the other is the top right, we do need to know which direction we are traversing so that we can place the character at the appropriate row. Let's run a couple of simulations to understand this better. For this demo, we'll set direction as 0 when we are moving downwards and direction as 1 when we are moving upwards. To begin with, I will be 0, row will be 0, and the direction will be 0 as well as we are going downwards. So we'll append p to the first row, that is row number 0. For the next run, I and row will be incremented. The direction will stay as is. The next character is a. We'll append a to second row, that is r is equal to 1. For the next run, both I and row will be incremented to 2. The corresponding character is y. So we'll add y to row number 3. As we are now at the last row, we cannot increment the row counter any further. So we need to now switch the direction and start moving upwards. So for the next cycle, my row will be decremented to 1 and the direction will change to 1 as well. I will continue to be incremented. The new value is 3. The corresponding character is p. So p will be appended to row number 2, that is r is equal to 1. For the next cycle, I will be 4. Corresponding character is a. The row will be decremented to 0. The direction will stay as is. So a will be appended to row number 0, that is the first row. As we are at the first row, we can't decrement the row counter anymore. So instead we'll start incrementing it and switch the direction to 0. This means that we are going in the downwards direction. We'll repeat the same cycle multiple times until we have iterated through all of the characters in the input string and characters are appended to the array at the appropriate rows. Once the iteration is complete, we'll combine all of the characters at each row and build our output. With this solution, our time complexity is O of n, where n is the number of characters in the input string, and the space complexity is O of r, where r is the number of rows given to us. This is because we are using an array of size r, that is the number of rows, to record all of the characters. I hope you were able to understand this solution. Now let's discuss an alternate approach where we can save on some space complexity. In this approach, we'll try to identify a pattern between all of the characters for each row, which will help us derive a formula to solve it. I've drawn the zigzag converted for the same input string but different rows. The first one is for 4 rows and the second example is with rows 3. Let's start with looking at row number 0. In the first diagram, all of the elements in the first row are at multiples of 6. The first one is 0, then 6 and then 12. Similarly, on the second example, the difference is 4. So they are all on multiples of 4, 0, 4, 8 and 12. As the difference is consistent in each of the example, we should be able to derive a formula which applies to both the examples. I think the formula that works is 2 into r minus 2, where r is the total number of rows in each of the tables. Let's verify it on the left hand side. So the total number of rows is 4. So 2 into 4 minus 2 will result in 6. And with the row is equals to 3, 2 into r minus 2, 6 minus 2, which will give me 4. The formula aligns with the difference that we are expecting in both the examples. Now if we look at the last row in both the examples, the difference is again the same. On the left hand side, we have the first element from 3. After that, the next element is at index 9. So difference is still 6. And same pattern on the right hand side. The first element from index 2. After that, we have 6 and then 10. The difference is consistently 4. So we can use the same formula to calculate all of the characters for the first and the last row with any given inputs. Now let's focus on figuring out the formulas for the remaining rows. If we look at row number 1, the difference between the two numbers is still 6, but the only change is there is one more element or character in between. Now we need to figure out if there is a pattern to all of the new characters that are appearing in between for each of these rows. We have a similar problem on the right example as well, where the difference between the two numbers is still 4, but there is a number in between. Earlier we used the formula 2r minus 2, where r is the total number of rows. I think we can update our current formula to match this pattern as well. The updated formula will be 2r minus 2 minus 2 of small r. The capital R is representing the total number of rows, while the small r represents the current row. If we apply the variables here, the total number of rows is 4, so 2r will be 8 minus 2 of small r. As we are looking for the first row, the r will be 1, so 8 minus 2, so the result will be 4. This result aligns with the difference between the current value of I and the next element that should be added to the particular row. For example, if you have added I is equal to 1 character in that row, I plus formula output, that is 1 plus 4, so the character at index 5 should be added to that row. We verified that the formula works with r is equal to 4. Now let's verify it for the example where r is equals to 3. 2r will be 6 minus 2 of small r, which will be 2 again because this is row number 1. So the output will be 2. As the difference between the first and the second character is 2, the formula fits perfectly. This formula works with row number 1 in both the examples. We need to make sure it works with all of the rows in the middle. Applying the same formula, 2r is going to be 8 minus 2 of small r. Here the value of r is 2 because we are looking at the second row. So the result will be 4. So we are looking at 8 minus 2 minus 4. The output is 2. As the formula output aligns with the difference that we are expecting between the two characters on row number 2, this formula can be used for all of the middle rows. With this solution, our time complexity is O of n, as we are iterating through all of the characters in the given input string and placing them at the right position, while the space complexity is O of 1, as we are using the two formulas to calculate where the character should be placed in the output. I hope you were able to understand the explanation. Let me show you how we can implement this solution using Java. Here's the solution in Java. In the main method, I start by validating if the number of rows input is equals to 1. If yes, then we can simply return S as the output. After that, I'm using the StringBuilder variable to create a result and initialize the cycle length, which is the formula that we just discussed, 2r minus 2, where the r is the total number of rows given to us. After that, I'm starting a for loop to iterate through all of the rows and running a nested for loop to calculate all of the characters that should appear in the particular row. Inside the nested for loop, I'm adding the character at I plus row index into the result string builder. If you're looking at the first or the last row, it will use the formula 2r minus 2. After that, we take care of the middle rows. So I'm checking if the row is not equal to the first row or the last row, and also make sure that the formula is not going out of bounds. If all of the conditions are met, I am taking the character at I plus cycle and minus row and adding it to the result string builder. Once the for loops are complete, we convert the string builder into a string and return it as our output.
This code, when submitted on LeetCode, beats nearly 100% of the submissions in terms of runtime and 87% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.